River, and you can probably see the town of St. Helens over there in the distance. And St. Helens has been pushed over by this delta. Now, this eruptive period was most likely about 20,000 years ago. That meant that the mountain was was covered with snow and ice, and so consequently, the mud flows and lahars were much larger because there was more water available. Now you can see the hill over there, and that hill is where the Lewis River comes down and is diverted all the way through here and around and meanders around to here and then empties into the East Fork before it goes into the Columbia. Now you can see just how big this delta is off of Woodland, the Woodland Delta. And the volume of material that came down in the Cougar Age was quite significant. Now some of the larger deposits seem to be from dammed lakes that happened during that period. Obviously there'd be quite a bit of water for the lakes to form and then overtop and then come down in the Lewis River and create this massive delta. So notice the wonderful soils in this delta, and the interaction between the Columbia, the Lewis, and river on this delta has produced some very fine soils, and because of the bank storage, there's lots of water. Consequently, this is a very good farming area. We're at Horseshoe Lake Park in Woodland, Washington. Horseshoe Lake is a result of one of the eruptions of Mount St. Helens. It was so large coming down the Lewis River that it blocked the drainage of the Lewis River, and consequently it is trying desperately to reestablish its direction, and they have quite a bit of flooding in Woodland, because normally the river would go into the Columbia River at a V shape, and unfortunately it is diverted into the East Fork of the Lewis River. It doesn't even dump into the Columbia River anymore. It goes into the East Fork first and then into the Columbia River because of this huge delta here. Let's take a look. All of this material, all of what you see here, all of this material, and we'll get a better shot of it later, is material that has mudflow material that has been dumped into the Columbia River drainage. And actually, this mudflow material, this lahar material, pushes the Columbia River over into St. Helens, the town of St. Helens and Clatskanie. Pushes it way over there. That's how big this delta is. Now this here is Horseshoe Lake recreation area, and the lake makes a horseshoe. Well, why? It makes a horseshoe because this used to be a meander in the Lewis River, and so this meander was cut off by the mud flow, and consequently it's now an isolated lake. The water really doesn't have an outlet or inlet. Instead, it just is basically the same level as the Lewis River through bank storage. Now, rivers do have bank storage. What bank storage is the water that's in the river percolates through the sediment, and whenever there's a hole that is deep enough, it'll fill with the water. I know you're familiar with Delta Park, and Delta Park oftentimes it has ponds on it simply because of the Columbia River bank storage. The same elevation, same elevation. It's just bank storage of the river. In fact, Columbia River, they have evidence that the bank storage of Columbia River goes all the way back to Battleground, Washington. So that's about 10-15 miles of bank storage. And here we're looking at all of this land, all of these farms. All of this is the delta off of the Lewis River. Here we are at the other end, or on one of the bends of the river on Horseshoe Lake. You can see the freeway over there that we came off of, and you can see this huge old meander. Here's the other end of the lake, and I'm going to drive along so you can see the entire horseshoe shape of the lake. The background noise is the freeway. The freeway runs right along it. And here we are at the other end where we started. Here's an aerial picture of what we're talking about, of the meander that is cut off that we call Horseshoe Lake, blocked by the debris and mud flows. Well, now we're on the Kalama River, and you can see that there's quite a bit of material that has been deposited, and now we have the Kalama Delta. Okay, huge deltas made of a lot of volcanic material. One of the things that I have noticed here is this formation that is in the off ramp. This formation meanders down the freeway. They've cut through it, but it's made of volcaniclastic material, layer upon layer upon layer. And my guess is that it's probably volcanic material from Mount St. Helens, but I'm not quite sure which period. But it obviously filled the valley, and now the sides of the valley are gone, and since it's welded together, it ends up being very resistant to erosion. Up on the hill over here are these wonderful flat terraces that people have built their houses on, and those terraces are the result of the glacial flood and the damming right here at the junction of the Coast Range and the Cascades. Very interesting, dynamic place. Here's a little better view of this delta that they've built industry on. Unfortunately, the land here is so good for growing, it's almost a pity that they'd have a steel mill here. The hillside that's in the distance is actually part of the Portland Fault. You may have heard of Trojan Nuclear Plant. I stopped here because I wanted to show you where the Columbia and the Cowlitz River met. That's where they dumped all of the, along the Cowlitz River, where they dumped much of the spoil that was in the stream. They pumped it out of the stream. And if you take a look at the material here, you can see that it's mostly sand and pebbles and what have you. So as a building site, it's probably not very stable, especially with the bank storage of the river, of the Cowlitz and the Columbia. Now we're expecting a probable earthquake at the coast. If it happens and it's above an 8.5, maybe even a 9, all this sediment that you see here and anything built on it is going to liquefy. It's called liquefaction, and it will sink. And as it sinks, anything that builds on it will be damaged. But they're selling it, and we are in the floodplain of the Cowlitz River. These are the factors that have to be present for liquefaction to occur. Not all debris is liquefactionable. I decided to what liquefaction can do if it happens. This is a picture of some damage. I decided to explore the terraces that were cut in the sides of the hills around Kalama and between Kalama and Kelso, and I was really surprised. I found not only the terraces but some channels that were cut into the side of the hill, and I'm going to show them to you right now. Okay, and here we go down in these very deep. Now we're about 500 feet, so the lake waters that drain must have been a little bit deeper than the water that was in that created Lake Allison, that was behind up the Willamette Valley. So these are pretty deep cuts into the sides of the hill, causing terracing. And look at this one. Here's a good valley that was cut by the floodwaters going through here and emptying out into the ocean, basically. Now remember, this was back during the glacial ice ages, and so the coastline was 25 miles further out. So the gradient and the speed of these floodwaters was quite rapid. It's estimated by the size of the boulders that it carried. It estimated that it must have been going about between 50 and 70 miles per hour. That's got a lot of energy. Here we go into another flood channel right here, and terrace. I've never done this before because I never had time, but now I have time and I can show you things that we couldn't get a bus to do. Here we go into a very deep flood channel. Okay, very deep. Looks like part of it is sliding too. Anyway, kind of interesting to me to be able to see these. Now here's a terrace that was cut into the side of the canyon, right here, nice and flat. These were wave action terraces, by the way. The waves on the water that were cutting into the side. There's another really nice, big, deep flood channel. Well, we're here at the Castle Rock Fairgrounds, and all this material that you're looking at right here is from the 1980 eruption of Mount St. Helens. And you can see these buildings that were in the fairgrounds were buried by the mud flow. Some have been lifted up, but the main building over there, as you can see, is still buried. They dug it out. Let's take a look here. Pretty soft material. Anyway, taking a look, you can see that the Castle Rock Fairgrounds were buried by the mud flow. Not only that, but the ball field that was here, the school, Castle Rock High School, was in the floodplain, so it was buried too. I want to take a look at the area where the ball field was to see if they left the softball backstop. See, all of these buildings have been dug out. Rather interesting. Now, this is all new material that was deposited here in 1980. That little log cabin on top was built after that. All these buildings that have been dug out of the fairgrounds are the ones that were surrounded by mud. Now, back in 1980, when I came here, there was a ball field, a softball field, where that cabin is up there. It was right next to this fence that I'm walking along, and the top of the backstop was only a couple of feet. I could step across the top of the backstop. They've removed it and moved it over to the south, and all this material that you see here is from 1980. It's this material that they're building these houses on. Well, somebody's been scooping out a bit of it because it's pretty good rock, and it contains all sorts of rock from Mount St. Helens in 1980. And this is that lahar material. Now, mind you, this was probably pumped out of the Toutle River, but a lot of it was put in place when the mud flow came through here. So you can see it's pretty loose rock and full of material that came from Mount St. Helens. Here's a piece of pumice right here. Here's a piece of andesite, more andesite there, just full of rocks. Here's a piece of andesite right here, cobble. Very, very loose material. Any sort of earthquake activity along the area here going to make whoever's built on here sink. Or possibly one of the problems is these spoil piles have created sort of a culvert all the way up to the mountain, at least to the sediment retention structure. So if a mud flow happens, which has happened in the past from these lakes breaking out, or in what I said, the glacier melting that's in the crater, okay, in a thermal event, wouldn't have the distributary area that it had back in 1980, because these mud flow deposits, these lahar deposits, spread out along the Toutle River Valley before they even got to the Cowlitz River, and now they don't have that. And so it'd be sort of like a great big cement chute right into the Columbia. Let's hope it doesn't happen. The 99 bridge, Highway 99 bridge, which was definitely at risk back during the eruption of Mount St. Helens, when it was sending vast amounts of material down through the Toutle River. This is the Toutle River. It is where it intersects with the Cowlitz River, and you can see across the way deposits not only from 1980, but some of the deposits over there are from other eruptions that came out this side of the mountain. It was interesting. Used to bring my classes here back in the 80s, and I remember one young lady mentioned that by gosh, we could see a person, one of the 57 that were killed, wash out into the stream here, because a set of logging truck tires and rims and the hauling mechanism fell out of the cliff face over there. This is where they also measured the amount of sediment that was going to be deposited into the Columbia River. They had their equipment right here on this bridge. Now, taking a look at all this, quite interesting after 41 years. It sure looks different than it did back in 1980. There was no color. The trees that were on the banks were baked and died. All these trees, especially the deciduous ones that were down next to the river, they basically died, and these are all younger than 40 years. Now the firs over there, I imagine, were probably a little higher, and so they possibly were here in 1980. I'd have to core them with a tree core to find out, but I imagine they were here. Look at the size of this spoil pile that was dumped on the side out of the Toutle. The way they did that, sometimes it was with a shovel, great big shovel, and other times what they would do is they would make sort of a pond structure, and then they had Avid Industries had a sediment pump that they used to keep the channel clear on the Columbia and other rivers, and they brought that down here and pumped the sediment out of the river into these little pond structures. And so you can imagine, if you happen to be built on something like that, it's just nothing but really fine material out of the bottom of the river. You're going to have, you're going to have foundation problems, just nothing supporting it. I know it's kind of noisy here, but this is the I-5 bridge that the mud flow was hitting the bottom of back in 1980 on May 18th, May 19th, May 20th, and they closed the freeway. They were really worried that this bridge might give out and be taken out by the mud flow. All of this material that is along here has been deposited in 1980.